I'm tired.
Yes, you're right. Energy is ability to work.
Energy is ability to do some work.
Do cars also use energy?
Yes, they use petrol or gas as energy. So, petrol or gas has energy which make things to move. All things require energy to move.
So we can store energy?
Yes, energy can be stored, like in the petrol tank of a car.
All things need energy to move. Energy can be stored.
Oh, I used so much force and energy, but very less work was done.
Yes, Jimmy, you applied a lot of force and you used so much of your muscular energy, but you could only move few things. Hence, less work was done. Now we would see different types of energy.
Oh, this bulb is giving so much of light.
Yeah, it works on electric energy.
Electrical energy.
Hey, this fire is giving so much of heat.
This is called heat energy.
Heat energy.
Okay, tell me, what energy is this?
You're doing work with your muscular energy.
Muscular energy.
Oh, it is so hot here.
You know where heat is coming from?
Yeah, I know. It is all coming from the sun.
Yes, you're right. Energy which comes from the sun is called solar energy.
Solar energy.
You know, this bulb at night does not need electricity. You see that panel?
Yes.
It stores solar energy during the day from sun, and at night it gives that energy to the bulb.
Oh, so this bulb works on solar energy.
Let me show you something.
Hey, water has so much force.
Oh, this is energy of water which moves things.
This is called water energy.
Yeah, this is called hydro energy because water is also called hydro.
Hydro energy.
Oh, these are big fans.
These are called windmills. They produce electricity.
Hey, listen. Wind helps in electricity also.
This is called wind energy.
Wind energy.
Hey, listen. It's getting so windy.
Let's go home.
So that was a nice talk between kids regarding force, work, energy and the power. Now some more examples based on this heat and work. This we have seen. When work is done only when a constant force is applied on an object causes the object to move in the same direction as the force is applied. So if this is the body and the force is applied which is constant, so work is said to be done. What is considered as a work done in physics? You push a heavy shopping trolley for 10 meter. If you lift your school bags upward by 1 meter, these all are said to be work done. If the distance traveled is 0, then these are not the work done. So you push against a wall, that is not work done. Jumping continuously on the same spot or holding a chair and walking around the classroom, that is also not a work done. Work can be calculated by force, multiplication of force N and distance moved in the direction M. SI unit is joule, that we have seen. So work done, if this is an example, if you are helping to push your mother's heavy shopping cart, let me see this example. The shopping cart is moved with the force of 50 Newton for 200 meters. What amount of work is done? 50 Newton load is travelled with the distance of 200 meter. So 50 into 200, that is 10,000 joule or 10 kilojoule. So we can say 10 kilojoule work is done when you travel to 200 meter with 50 Newton of load. Then one more example, a Jack put on his backpack of weight 120 Newton. He then starts running on a level ground for 100 meter before he started to climb up a ladder up a height of 10 meter. How much work was done? Here the load is 120 Newton, and along the horizontal line, that is along the ground, it moves 100 meter distance. So from physics point of view, no work is done on peg at a level ground. Reason why? The lift is perpendicular to the movement, so work is done on peg when only when Jack climbs up a ladder. So work done is equal to 120 into 10, that is 1200 or 1.2 kilojoule or 1200 joule, because the lifting is not here. Some of the aspects are discussed. Energy means capacity to do work, unit is joule. These are the forms of energy: electrical energy, sound energy, nuclear energy, light energy, heat energy, kinetic energy, potential energy, and chemical energy. A form of energy that the body in motion possesses. Then amount of kinetic energy of a moving body depends upon the mass of body, that is kilogram, and velocity, that is meter per second square. So when neither mass nor velocity of moving body is increased, kinetic energy will remain same. If one of them increases, then kinetic energy will increase. That is equal to 1/2 mv square, mass into velocity square. This is the form of kinetic energy, that is 1/2 m into velocity square, 1/2 mv square, and unit is joule, kilogram, meter per second square, whole raised to square. So unit is same as the unit of work done. Kinetic energy is equal to 1/2 mv square. If the mass of this car is m and it is moving with velocity v, as the mass is higher, kinetic energy would be higher. So now this is an example. Find out the kinetic energy of an empty van of mass 1000 kilogram moving at 2 meter per second. So 1/2 into 1000 into 2 square, that is 2 kilojoule. That is the kinetic energy of mass. If the van is loaded with the goods and if mass increases, say 2000 kilogram, then and it's moving with the same velocity, then kinetic energy of mass would be equal to 1/2 into 2000 into 2 square, that is 4 kilojoule. So the kinetic energy of empty van is less and kinetic energy of loaded van is more. And if the velocity of van is increased, say 4 meter per second, then a unloaded van kinetic energy is equal to 1/2 into 1000 into 4 square, that is 8 kilojoule. So we can say if the empty van is moving with higher velocity, then its kinetic energy would be much higher than loaded van, and the energy of loaded van is higher than the energy of empty van. So it's difficult to break the van when it is loaded as compared to empty van. For formula, kinetic energy, change in kinetic energy is double when mass is doubles, kinetic energy doubles, and when velocity is doubles, kinetic energy increases by 4 times. That we had derived from this example. Now one example of kinetic energy. A motorcycle accelerates at 2 meter per second square from rest for 5 seconds. Find the kinetic energy of motorcycle after 5 seconds, and mass of motorcycle is 200 kilogram. So velocity of motorcycle after 5 seconds is v minus u upon t, that is 10 meter per second. So kinetic energy of motorcycle at 10 meter per second is equal to 1/2 into 200 into 100, that is 10 kilojoule or 10,000 joule or 10 kilojoule, right? So that is the kinetic energy of motorcycle. Then potential energy. What do you mean by potential energy? So potential energy is the energy of the object by virtue of its position from its bottom line. It is a result of its position from the given condition. Two common kinds are gravitational potential energy and pressure energy. Energy that can be possessed by an object due to its condition is elastic potential energy. For example, spring, rubber, balloon with air and slinky. If you compress the balloon of air, it possesses PE or pressure energy. Then gravitational potential energy means, in physics, ground level is normally assumed to be zero datum level, and any object that is at the ground level having a zero potential energy, and at certain height it is having some potential energy. When a chair is lifted from ground at a distance 1 meter, its potential energy remains same. But if it is elevated at certain height of the building, then its potential energy is increased. So this is the gravitational potential energy, this is the building, and this is the block which is at a height of h. So potential energy of this block is m into g into h. So mass of the body m, g is the gravitational acceleration, and h is the height at which it is located. So GPE is equal to mgh. Now one example, if you lift a bag to the top of your table, what can be said about gravitational potential energy? It will increase. If lift the same bag on the moon, say here, lift the same bag on the moon, what happens to GP? It will also increase. And the earth and moon, both on the moon, less increase in potential energy because G value is less, and on earth it is more because value of G is higher. Now you lift a set of books of mass 3 kg from 2 meter. What is GPE gained by the books? Take G is equal to 10 meter per second square. So mass is 3 kg, distance is 2 meter or height is 2 meter, G is 10. So 60 joule is gravitational potential energy of that book. And find the work done by you when you lift the book. So work done is equal to force into distance. Force is m into g. Distance is 2 meter. So 3 into 10 into 2, that is 60 joule. That is the work done with this exercise. Now conservation and conservation of energy, that we will see next time. Now what is the system? The thermodynamic system is defined as the quantity of matter or a region in a space upon which attention is focused for the analysis of the problem. So with this, let me conclude the today's talk. In today's discussion, we have derived various entities used in mechanical engineering. We started from force, then force, work done, power and energy. We will continue with some more details in the next time. Thanks to all of you.